Welcome. Welcome to my office, such as it is. So we're no longer on campus, and I am basically converted my basement into an office/workshop. So I'd like to just start off giving you kind of an overview of what I've been playing around with for the last couple of weeks. So I've been getting into flying quadcopters, and a lot of what I like to do is work on designing of different parts for it. So you can see here that I had a crash yesterday, and the quadcopter wasn't in quite the mode that I thought it was going to be in, so I took it off and it just landed right down. So broke a couple propellers, but luckily enough I have a set of new propellers, so they're going to go on today. But the blue pieces here are things that I've designed in SolidWorks, and I have attached so this is for my battery, this is for my radio receiver, this piece here is for my GPS, and hard to get a look on the inside. Maybe you guys can. I'll have to take a look once I process the video, but there's a bunch of little plates in here for holding the what's called the flight controller and the ESC, the electronic speed control. So that's one of the things I'm working on. I also like a site called Flight Test on YouTube, and they have lots of plans for making DIY planes out of foam board. So this is one they call the Tiny Trainer, and I had it out yesterday. So I've again used, I've 3D printed, well actually, so I should mention that, right, that over here are the two 3D printers that I have. This one is the Prusa Mini. It has a smaller build plate, and this one is the Prusa MK3S. You might see that it's disconnected and taken apart right now. That's because there is a broken wire here for the heater core, so I've had to order a new one of those. But anyway, so most of the stuff that's in blue here, and actually some of the pieces in black here on the bottom, were all 3D printed. These were pieces that were meant to just support the dihedral angle. This is what they refer to as their power pod, and I had a piece that I made just to kind of hold the front wing down. But I was flying it, and the electronic speed control kind of burnt up. My son was out there with me, and he said, "Dad, there's smoke coming out of the plane." So we're going to have to work on this one a little bit more. But I also ended up breaking the tail, so maybe we'll do it with duct tape. Maybe not. We might have to rebuild the plane. And so you can kind of get there's sort of a theme going on here. This one, let me actually turn the camera back to the table over here. So this is my newest one that I'm working on. This is what they call a 5-inch racing frame. So I have my motors connected, but I don't have a 4-in-1 speed controller here. So I have these individual speed controllers, and what I've decided, let me see, this one actually is out. So I want to try to mount them onto the center here. Normally they would go on the arms, but I'm trying to see if I can avoid that, because especially I've had to rewire some of these motors and it's getting kind of bulky. So what I've done is there was a couple iterations here, different types of pieces that I've played around with, different configurations. Some were just straight boxes, and this is the one I finally have come up with. So it's screws together, and this contains two, and it looks like it's going to be able to mount right there on the middle, and this will go to these two motors, and I'm going to need to put a second one on that'll go off for these two motors. Look around at the different types of configuration, and then the flight controller and there's going to be a power distribution board to bring the power out to the different motors, plus a flight controller, and then there's a top to it, and these are carbon fiber frames, so supposedly these are indestructible. This one is to replace one that I lost the other day. It kind of hurt, I was flying and I got a little ambitious and I was heading towards a tree, and instead of letting it crash, I decided I would try to save it, and off it went into the horizon. And the eyes aren't as good as they should be. They once were. So instead of trying to, I should have just let it crash, but you kind of have in your head that you spent money and time working on it, so you want to try to save it as it's getting further and further away. And this one, it all of a sudden just turned into a dot and disappeared. So that's when I cut the thrust. And it's in the woods somewhere by my kids' high school. They were at football practice. So it's gone, $200 down the drain. So this is something I've been playing around with for the past couple, year and a half. So these are just different variations of making a completely 3D printed quadcopter. So I kind of had put this aside for a while because it would just break. I mean, I had it. I had another one that I had done that I really liked, but they keep breaking on crashing, right? Not landing, crashing. But what I'm starting working with now are flight controllers. This one over here, it's got the GPS module and it has a flight controller that allows it to essentially like the DJI camera drones. So I can do missions with this and auto land it and things along those lines. So now that I have that, I'm probably going to come back to a 3D printed drone aspect. But for the arms, I'll probably use aluminum. So, because these are the things that are always breaking. I thought this was a pretty nice configuration, but no matter what, at the root connection, right, that's what you would call that, as soon as when it lands, it puts an awful lot of torque, and they tend to break at those locations. So we'll try to do that. So either aluminum or possibly just some type of polycarbonate, but there's a lot of flex in these, and when there's a lot of flex, the quad has a little hard time being too flexible, so we'll work on that one. So this one I'm working on right now, probably talk a little bit more about this as time goes on, is going to be a thrust stand for measuring thrust from the propellers. So this was one that I actually stole from Professor Willis, so I got to give it back to him one of these days. But why I'm talking about it now is that I've actually worked on some hold-down designs. So normally, when I got this, there were just some screws that were drilled right through the 80-20. That's what this aluminum extrusion is called. So I wanted to do something a little bit more, better, shall we say. So this hold-down now will just slide right in here. And it will attach using one of this little insert here that allows you to screw it together. So it'll clamp tightly here, and I'll be able to screw it down here. So I think I'm doing overkill. I actually have 3 of them on it already. And this, you might recognize, well, some of you might recognize that's a load cell. And this is just a quick test. I'm going to 3D print mounts for this, and this load cell gets connected to an Arduino board, and it's got a linear output. So I'll be able to put this piece here. The propeller or the motor is going to mount up here. This is the one I have. So I have a couple. I'm going to make a 3D printed mount for the motor, and the propeller will come here. So as the propeller pushes in this direction, this arm is going to press down. Now, those of you that are taking statics, you'll note that there's a point of rotation here. So the moment, this is the moment arm, and this is the thrust from the propeller, and then this is the moment arm from here to here on this. So the moments are going to have to be equal to each other. So once I am able to calculate the load here, I'll be able to get the thrust of the propeller. It'll be hooked up to this. This is what's called the shunt resistor. So it's calibrated resistance, I'll be able to measure the amperage that goes through it. So I'll be able to plot the current draw as a function of, or thrust as a function of current draw. And these are just little IR sensors. So a receiver and a transmitter, and these will be mounted out here somewhere. So, which every time the propeller passes through, it'll break the beam, and I'll be able to get an RPM rating as well. So this is what I'm a little excited on. I have a board up here. There's two of these. You might see some of these in a normal semester. You might see the electrical engineering students playing with something like this down in the makerspace. So this is a device made by Analog Devices, but it essentially works as an oscilloscope. So I could use this to measure the RPM rate and the current draw, or I might use one of these from National Instruments. This is called a National Instruments MyRio. So it's sort of a kind of souped up data acquisition system. Not sure. I'm probably going to run out of time doing that. So where are my other little projects here? So this one is, you might recognize these as the little LEDs. So my son wanted to put them in his room, but they only come with these crappy little remote controls, and you really can't program that much stuff into it. They're mostly just designed to do a couple things. So I figured out, I took it apart and figured out that I can access and turn it all on just using an Arduino. So that's one step. So now I know how to control it. And what I'll probably end up connecting it to, this is a little kind of miniature Arduino board made by Adafruit. Great company if you're interested. So it's called the Adafruit Feather. And this has Wi-Fi capabilities. So what I'll be able to do, again, I'll have to 3D print an enclosure, but I'll put all this into the enclosure, and I'll be able to help my son write a little program so that he can wirelessly control the LED lights. Right now, it's just being controlled using a simple, this is an IR remote control, a little IR LED here and a little IR receiver here. But we'll be able to do it over Wi-Fi. So that's kind of exciting. Over here, I am in the process of, so when you're flying quadcopters, a lot of people will do what's called FPV, first person view, and they wear all these goggles. Well, I haven't kind of graduated to that. First, the goggles are really expensive, and secondly, I get motion sick. So I'm sure I'm going to get really motion sick if I have the goggles flying all around. But what this you can do is mount a screen onto your remote control, something like this, and you can see the video that's coming from your quadcopter. So this is a little cheap screen that I got from Amazon. It's actually funny. You look for these screens on Amazon, they're sold by 30 different sellers, but they're all the exact same screen coming from some single distributor in China. And this is a receiving module. So it's pretty simple to receive. I mean, a lot of wires stuck here, but there's only one wire going to the monitor. So it's got a power cable and just a single video feed. So you can just see I have a single video feed connector here. And then I splice both the power. So there's power for this and power for this. Both require 12 volts. So handy dandy, you have about 1,000 of these in anybody's given household. So this is a 12 volt transformer and powered the whole thing up. So this then will receive the output from this little setup here. So this is the video transmitter. It's got a nice little antenna on it, which is going to connect right onto the drone. And this is the tiny little camera that'll work on it as well. So I'll be making additional videos, maybe one a week, just to kind of let you guys know what I'm up to. And I'll show you how all these are set up. So you can kind of get the feeling right now that there is in any given modern hobby these days that you as a mechanical engineer might want to get into, there's always electronics involved. So I think it's really cool, and any sort of hobbyist stuff that you're going to get into, I think, be something that you might want to think about. And of course we have the very toy remote control quadcopters. So this one I had a couple years ago. So the battery's dead, so I'm going to try to take this thing apart. And so I found this in a drawer the other day as I was cleaning up my office. And I have this one too. This one I really need to figure out because I am missing the remote controls gone. And this isn't IR. This actually has a radio receiver, so 2.45 gigahertz. So, standard kind of frequency. So I'm trying to find if I can figure out how to get the control codes for this to see if I can get this thing to work. And lastly, over here, move me back this way, is that I have a Raspberry Pi here. So right now, neither of these are networked, so I keep having to leave my computer, walk around here, and load the files in for the 3D printer to work. So hopefully, going to make it work so that I can control them over the Wi-Fi with the Raspberry Pi. All right, so that's me right now. I'll give you kind of a quick. So I'm standing behind the camera now. So finished the basement a couple of years ago, and it was supposed to be for the kids, but now it sort of became mine. And my wife suggested about a year ago, well, last Christmas actually, that I would move my office downstairs. So I've kind of sort of moved all over the place. So there's my desk, kind of messy right now, and there's a heater in the back. And I'm not going to go all the way around because the wall that has all the windows on it is really messy right now. So I'm still working on that. If you're looking at what that is on these stock shelves over here, I will have to admit that yes, this is my comic book collection from the 1960s and 1970s. Unfortunately, they're not rare anymore. I was hoping that they would be rare enough that I would be able to send all my kids to college, but that is really not the case. So listen, the other videos that I'm going to be posting will be how to get into VLabs, how to start up SolidWorks. That we're going to be using a service called Solid Professor that is going to replace the lecture. So a lot of you were wondering about why is the recitation there as a TBA. Well, about a year and a half ago, or 3 or 4 semesters ago, I decided that it was kind of pointless for me to have 100 or 150 students in a lecture hall and try to show them how to do stuff on SolidWorks. So this is sort of in lieu of a textbook. I believe the current cost is $75 for the year subscription. So it's a year subscription. So not only is there stuff on SolidWorks, but there's lots of other things that you can take a look at. And in the video, I'll go through that as well. All right, so looking forward to virtually meeting all of you. And I guess next week, during your regularly scheduled lab section, is when I will virtually meet every one of you. All right, until then, I'm Professor Sullivan.